Hello, and welcome to New Scientist Weekly, your curated selection of the week's science stories. I'm Timothy Revel in London.
And I'm Christy Taylor in New York. This week on the show, we've got the largest realization yet of the bizarre thought experiment known as Maxwell's demon, which is sadly not as demonic as I had hoped. We'll also talk about how Ukraine is using AI in its efforts to remove Russian landmines and strange tricks from both leeches and cashew nuts. Though I will say one of these is kind of scary, and you can guess which.
Plus, how chimps appear to practice a form of medicine. But first, have you ever wondered why some people seem to be immune to COVID-19? You know the type, everyone around them has been infected, they're stuck in a house filled with COVID, yet for some reason they never test positive or show any symptoms. Well, now years after COVID-19 first emerged, we may finally be starting to grasp why some people have it this way. Assistant news editor Alexandra Thompson is here with us to explain the news. Hi, Alex.
Hello.
So am I correct in thinking that in this study it involved deliberately trying to infect people?
Yes, so volunteers who apparently didn't mind risking a sore throat.
So these poor participants, did they just put them near people who had tested positive, or was there some more scientific way of doing this?
So a bit more scientific. These volunteers had the original SARS-CoV-2 variant sprayed up their nose, so it's marginally less unpleasant than what you had in mind.
Yeah, marginally, I would say. But so if this was all about testing whether people are naturally immune to the virus, how did they go about finding people who hadn't already been exposed or had the vaccine? There can't be that many of those people left now, right?
Well, this study was carried out in 2021 when restrictions were still high and vaccine rollouts had only really just started. So it wouldn't have been too hard to find people without any antibodies against the coronavirus. But it was still a small study, just 16 volunteers.
Gotcha.
So with these volunteers, they took nasal and blood samples both before the spray and 6 to 7 times afterwards over the next 28 days until they collectively had more than 600,000 cells. And during this time, the volunteers were also tested for the coronavirus twice a day. And the results were a pretty mixed bag. So 6 people tested positive in both their daily tests for more than 2 days. 3 tested positive in one of these daily tests, but not the other, for a maximum of 2 days. And the remaining 7 consistently tested negative.
Got it. So most of them actually tested negative, either most of the time or even all of the time. So what insights did we get from those 600,000 cells?
Well, the responses between those in the second group, those who tested positive now and again but for a short period of time, and those who never tested positive were pretty similar. So they both produce this substance called interferon, which helps the immune system fight infections, but they produced it in their blood before they produced it in the nose-throat area where the nasal samples were collected. But it was actually higher in the noses of those with a short-lived infection than those without any infection.
So was that the only difference between those two groups and then the groups with the full-blown infections? Interferon for some, COVID for others?
No, so those 2 groups also didn't have any active infections within 2 types of their immune cells, which are called T cells and macrophages.
Got it. So it all seems to boil down to really complex differences on a cellular level. So can we use these findings to predict whether someone may then be naturally immune to COVID-19?
We can't quite predict it at this stage, but the researchers did find those with higher levels of activity in a gene called HLA-DQA2 were less likely to have a sustained infection.
I suppose at this point in the pandemic, I kind of wonder what is the good in knowing whether someone has this natural COVID-19 immunity. The people who don't have immunity definitely already know it. And while vaccines maybe shouldn't be the only public health intervention, they're also widely available in high-income countries these days.
Well, I think that improving our understanding of the cell responses associated with COVID-19 protection will assist in continuing to develop and improve vaccines and treatments. But it is worth noting this study only looked at the original COVID-19 variant, which has long since been replaced by multiple other variants. So we're not quite sure whether these results apply to most of us who, at this point, we've encountered different versions of COVID-19, probably time and again.
We're well over 2 years into the Russian invasion of Ukraine now, and the Ukrainian government has an enormous problem on their hands: how to demine vast swaths of land while fighting still rages on. Matthew Sparks is here. Matt, you've spoken to Ukraine's minister who's in charge of demining efforts about how AI can help with the task. You want to tell us more about the problem first?
Yeah, so I had the chance to speak to Ihor Bezkaravania, Ukraine's Deputy Minister for the Economy, who says there's two main goals, really, keeping civilians as safe as possible and keeping the economy running so that the country can keep fighting.
I mean, that seems like a really sensible approach. And agriculture is an important part of Ukraine's economy, so I imagine they're going to maybe prioritize farmland for these efforts?
Yeah, that's a good starting point, but it's not quite so simple, unfortunately. Shelling and mines and various other explosives have landed all over Ukraine, meaning that some areas are going to be harder to clear than others. Some explosives are harder to dismantle. Some are more likely to not explode and hide away just under the surface. Some also churn up the fertile topsoil and dredge up sand from underneath, which ruins fields in the short term for growing crops. And some even leave chemical contamination that needs to be fixed before crops can be planted. So basically, choosing which areas to clear is a really complex equation.
Which sounds like a job for an algorithmic tool.
Exactly. So what the country's decided to do is build a vast AI model that sucks in all sorts of data, tax records, property ownership information, logs from agricultural records, satellite images, military and emergency services reports, and even data from mobile phone companies that can show you where population is densest. Then this model is basically being trained to pick the most important areas to make safe.
That makes sense and fits with other usages of AI that we've heard about before. How big a problem are we actually talking about here? Do we know how much area needs clearing?
Well, after Russia's invasion of Crimea in 2014, Ukraine was looking at a few hundred square kilometers that needed to be cleared. Now it's thought that up to 144,000 square kilometers could be mined.
Oh, wow. That sounds like an awful lot.
Yeah, clearing that all methodically, step by step, could take 700 years, they've worked out. So that's not really an option. That's why they're turning to AI. And even then, there's talk that some areas might need to be abandoned, sealed off semi-permanently, just like France had to do after World War I.
Absolutely tragic and a really horrible situation. Once the AI prioritizes which areas would need to be cleared first, what happens next? Presumably it's not that simple as you go out and you deal with the mines. It's not an easy process.
No, once the AI model pinpoints an area, then engineers can physically go in and they've got drones equipped with ground-penetrating radar and magnetometers, things like that. But those surveys, they're not foolproof. They can still miss things, and they can really only work at a rate of about 3 hectares per hour. But honestly, with 700 years worth of explosives already buried and the war still rumbling on, there doesn't seem to be any good news for Ukraine in the near term, at least. And it won't be until the war is over that the country can properly assess the problem and make a proper plan.
Christy, I'm not exactly a geocentrist, but have you ever wondered what life would have been like had Copernicus been wrong all along and, Earth actually was the center of the solar system?
Much less the universe. No, I've never wondered that. And honestly, Copernicus suffered way too much as it was.
Well, you're in luck. The Dead Planet Society, they've been working out what it would take to put Earth in its rightful place at the center of the solar system and what the consequences of that would be. And honestly, this episode is a real good one. That will be in your feed, available to listen to as of Tuesday.
And in case you missed it, last week I spoke to Lyall Liverpool about her new book, Systemic, which looks at how racism affects our health and the people who are working to counteract it. That episode of Culture Lab is already in your feed.
Now, humans aren't the only animals that practice medicine. Reports of chimpanzees using plants as treatments have been around for decades. And a new study this week looked into the effectiveness of their range of herbal medicines. Sam Wong, assistant news editor, is here to tell us more. Hi, Sam.
Hi. Yeah, so as you say, there's been a lot of research before hinting at chimps using medicine. One behavior that's been studied quite a lot is leaf swallowing, where the chimps, they take whole leaves and they swallow them without chewing. And that's thought to expel parasites from the gut, probably by mechanical means rather than any chemical effect. They've also been seen stripping bark from a particular shrub and chewing the bitter pith inside, and that plant contains chemicals that are effective against parasitic worms.
All pretty amazing stuff, but we've now got some more evidence. What does the latest study say?
Yeah, so Elodie Freeman at the University of Oxford and her colleagues followed wild chimps through Budongo forest in Uganda, and they recorded what the chimps were eating, and also they tried to work out when the chimps were ill, which is a difficult thing to do with wild animals, but they made a note of when they saw any obvious wounds. They looked at the feces of the chimps for signs of intestinal worms, and they even checked urine samples for raised levels of immune cells. So they did all that. They collected 53 extracts from plants that were consumed by chimps that were sick or injured, and they tested the effects of these plant extracts on immune cells and bacteria. 88% of them were active against bacteria that are pathogenic in humans, including antibiotic-resistant strains like MRSA, and all of the sampled species had anti-inflammatory effects.
Wow, that sounds really impressive. I do have to ask, do we know if the chimps are, actively choosing to eat these things when they're ill, or do they eat them anyway and it just so happens to help the ones who are ill?
Yeah, good question. Chimps have quite a diverse diet, but they're usually reluctant to try unfamiliar foods. And the researchers, what they saw is that the sick chimps would often leave the safety of the group to find these specific plants, and they picked out species that were only rarely eaten by this group. So the infrequency of those events does suggest that it's a targeted response to illness, but it's hard to be sure.
So if these plants have antibacterial effects, and you mentioned, things that affect us too, could we discover new antibiotics for people by studying them? I mean, it sounds like a good opportunity.
It's certainly possible. We don't yet know what the active ingredients are in these plants, but the researchers have stored the plant extracts, and they're hoping that we might be able to find new drugs by learning from our ape relatives.
Amazing. I feel like this should also increase our respect of our ape relatives just a little bit. And, I think I'm remembering there was also another recent study reporting a kind of medicine used by orangutans, wasn't there?
Yeah, so that one was just one observation of a single Sumatran orangutan, but they saw him chewing the stem and leaves of a plant called akar kuning that's used in traditional medicine, and he was putting the chewed up plant onto a wound on his face, and it seemed to heal up quite quickly. So, that one also needs a bit more investigation, but it might be that the medical use of plants is much more widespread than we think.
And from chimps, we move to demons. Not the usual kind of demon, but a very old thought experiment, which has turned out to be potentially useful. Reporter and writing demon Alex Wilkins, what on earth is this all about?
Yeah, so no one has to worry. There's no scary demons involved. The demon we're talking about here is a friendly little imp that was dreamt up by the Scottish physicist James Clerk Maxwell, who was puzzling over an apparent contradiction with the laws of thermodynamics.
Just dreamed up a friendly little imp, as you do.
Yep. I think physicists in the 19th century maybe had too much time on their hands. So this thought experiment has become known as Maxwell's demon, and it involves two boxes of gas separated by a weightless door, which is controlled by this demon. Now, the demon can let fast-moving particles pass through in one direction if he wants, and slower particles passing in the other direction, which would make one box hotter and one box cooler. But this seems to violate a key principle of thermodynamics, the second law, which says that heat must flow from hot to cold unless energy is used to make things go the other way. And physicists at the time didn't really see an obvious solution to this paradox. It seemed like it should be possible and also contravene this really central law.
An imp causing trouble, classic imp behaviour. I'm presuming that they've now worked this out, though, now, right? The second law of thermodynamics stands?
Yeah, they got there eventually. So in the 1960s, physicists working on information theory found that the very act of measurement requires energy, which is what the demon would have to be doing when it's kind of guarding the door and working out which particles can go through. And since then, scientists have found all sorts of examples where if the demon does have energy to do his deeds, the setup described in Maxwell's demon really exists. I reported on some research a few months ago, for instance, where researchers found that proteins can transport other proteins using a Maxwell's demon-like principle to operate.
Okay, but now new Maxwell's demon has dropped. What's special about this one? Some even more devilish paradox?
Almost. So all of these other examples that I reported on that we've seen before have worked on very, very small scales, often on the micro or nano, so like the width of a human hair or smaller. But researchers at the University of Cambridge have come up with a chemical example that works over centimetres. If we could transport James Maxwell back to our current day, he could have seen this happening with his own eyes.
So largest demon so far, what does it actually consist of besides the, I guess, less tiny demon, of course?
So it's essentially a chemical pump. If you imagine a U-shaped tube, its both halves are filled with a light-sensitive chemical called fluoroazobenzene, or FAB for short, and the bend, kind of at the bottom, is filled with water and these tiny pyramid-shaped molecules called coordination cages. These cages can contain specific molecules and carry them from one side of the bend to the other, so it acts as a sort of membrane or barrier. And in this experiment, the cage is the equivalent of the demon opening or closing the door that I was talking about earlier. When the researchers shine light on one side of the tube, the FAB molecule changes its configuration so it can more easily fit in the cage, which then makes it transport to the other side using these cages. And as a result, it accumulates on the other side of the tube, which goes against what would happen if the system were just left to its own devices. Then the researchers added another molecule, the hydrocarbon naphthalene, on the other side to one of the tubes, and found that when the FAB's moving in one direction, the naphthalene goes in the opposite direction.
Okay, so, I mean, it is easy to get caught a little bit up in the details with all this, and, a lesser podcast host might even say the demon is in the details, but not me.
Boo.
This thing, as I say, not this podcast host, but this larger Maxwell's demon, it could actually be useful, right? It's not just science for the sake of it. Not that there would be anything wrong with that.
No, of course. But as you say, this is actually potentially useful. So separating molecules from each other is a really sought after procedure in all sorts of chemical processes, from drug discovery to removing carbon dioxide from the air. And the authors, when I spoke to them, said that they hoped that down the line, they might be able to adapt this procedure to separate all sorts of molecules from each other, and that this might have some generality to it.
Generalized imp. Love it.
All right, Tim, I've got news of a 100-year-old scientific debate, and it's one of the mysteries of our time. It's now finally been settled.
This sounds good. Go on.
Well, it's not about dark matter. It's not about Maxwell's demon. It is about whether or not leeches can jump.
Yeah, that age-old mystery.
Yes. Well, okay, maybe not the mystery of our time, but it is one that researchers have been questioning for over a century. It is specifically about terrestrial leeches, which are ones that move around on land, not maybe the ones you might think of in, bogs or what have you.
Extraterrestrial leeches, you mean?
Extraterrestrial leeches, yeah. Not those either. Since the 1800s, there have actually been reports of these terrestrial leeches jumping, which is hotly contested. But now we finally got conclusive proof.
Okay, and by proof, you mean...
A video, obviously. A researcher at Fordham University in New York has filmed several different instances of leeches in Madagascar doing this jumping maneuver.
Okay, that does sound fantastic. Talk me through it. How does a leech jump? I can't quite imagine it.
Well, for starters, I want you to picture a leech, but these leeches have suckers both on their heads and on their tail end. The head sucker is... Yeah, I know. So many suckers. The head sucker is also how they attach to their hapless victims and get their blood meal. So that's where their mouth is, too. But most leeches also have this rear sucker called the caudal sucker. And that's equally important because they use that to help them move around, attach to plants while they wait for meals, and eventually attach to their meals. So they kind of have leverage while they are eating. But what the video, and we will link it in the show notes for anyone who really wants to see, the video shows that these leeches can also do something really cool with that tail sucker. They start by anchoring it on a surface like a leaf. They coil the rest of their body backwards. And then in one very quick motion, kind of like a cobra striking, as the researchers have said, they launch their body forward, unsticking their rear sucker and then becoming airborne. And that's it.
Yeah, and I guess if you listen close enough, you just hear that little whee sound as it flies into the air.
Exactly. And the researcher said she suspects that this behavior is likely really common, since it took her almost no time to get video evidence once she set out to do so. It's also very likely that other species can do this, and all of this jumping is possibly a way to get them onto or near unsuspecting prey like us.
All these species jumping, and we didn't know. Get out there with your phones and film some jumping species, definitely.
There are apparently only 3 terrestrial leech researchers in the world, so that might explain some of the gap in the data.
And they're all jumping for joy.
Tail sucker first.
All right, I've got one about another option for shipping fuel that would release less carbon into the atmosphere.
All right, what is it this time? Old tires?
No, but that is actually one that people are testing out. This time we're talking about the shells from cashews.
That's nuts.
Boo. When cashews
Touché.
Yeah, I feel like that one you deserve back. It's not actually that nuts, though. So when cashews are processed, their shells are removed. And these shells, they contain up to about 30% of a really energy-dense acid, similar to alcohol. And that liquid is already used in products like paint, and conveniently, it blends really well with higher quality fuel, which means you can use it in existing diesel engines like those that commercial ships already use.
It does seem like decarbonizing shipping is a pretty important goal, but it could also be really challenging. So how are we doing globally?
Yeah, we're not doing that great globally. So shipping contributes around 3% of total global carbon dioxide emissions. And there's an aim to reach net zero for shipping by the middle of the century. But there's been a lag in actually really moving in that direction. Last year, the industry was about 17% over what it needs to be in order to stay on track.
So cashews, is that the magic pill, the poison bullet, the silver wand? Is it going to solve all the problems?
That's the thing. It's probably not going to solve all the problems. Cashew oil is essentially joining the ranks of vegetable oils and animal fats that have been tested in ships this way. Those all emit CO2 when burned, but they emit much less CO2, especially in the case of this cashew shell liquid, and when compared to fossil fuels, but it still has to be combined with those conventional fuels, so the benefits are limited. So yeah, you'd absolutely be forgiven for wondering if this is perhaps a little bit gimmicky, but industry experts themselves have said that shipping is kind of grasping at straws when it comes to reducing emissions. The thing is, they can't afford to spend the same kind of money that airlines might for new technology, they say. There's not enough biofuel to go around, and so in the long run, what will probably be better, but ultimately more expensive, is converting ships to run on hydrogen-based fuels like ammonia. But that will take time too, because there isn't a lot of clean hydrogen being made just yet.
All right, so leeches can jump. The shipping industry will be hard to decarbonize. All right, I'm going to tell you something that I'm unapologetically excited about, just to leave us on a note of wonder. Titan, moon of Saturn. What do you know? Go.
It's the largest moon of Saturn, kind of yellow, methane seas. That's the famous thing about Titan, right?
Yeah, good. Okay, so yeah, Titan, it's the only known planetary body besides Earth where we know standing liquid persists. But that liquid is all hydrocarbons, such as methane, not water. And it actually also rains down from the atmosphere to form bodies of water with these distinct shores, little bitty lakes, big complex seas, kind of like the Great Lakes in the US Midwest, actively flowing rivers, that kind of thing.
It sounds very cool indeed. And this liquid, it sounds like it acts a lot like water does on Earth.
Exactly. And a research team wanted to figure out exactly how much like water it was acting, especially in the case of erosion. So do the shorelines that we see on Titan erode the way they do on Earth? And therefore, could that explain these sort of craggy, irregular shapes that you see on Titan shorelines?
And could they?
In short, yes. Researchers looked at Titan's largest bodies of water and compared them to bodies of water on Earth, and they then ran simulations where the coastal erosion on Titan came from either waves or just from kind of dissolving at the edges, or this third thing that involved like rivers kind of slicing into lakes. And they found it was these wave erosion simulations that really best matched a lot of the coastlines that we see on Titan.
That's a really great finding. You know, it's good evidence, but is there any plans to actually go and have a look?
Yeah, that's the thing. We need to actually observe this erosion directly, and the only way to really check this is to send instrumentation. But NASA is planning its Dragonfly drone mission there for 2028, so watch this space and this shoreline, I guess. That's it for this week. For more on these stories, there are links in the show notes, and for more great science and technology stories, visit our website, newscientist.com.
Thank you very much for listening. Bye.
Bye.
This podcast is produced by OG Podcasts. Find out more at ogpodcasts.co.uk.